push it to the limit, cause we're in it to win it, in it to win it, oh yeah.
Sir Isaac Newton created Newton's three laws that describe inertia, how force equals mass times acceleration, and how for every action there is an equal and opposite reaction. All the laws contain different types of forces which causes changes in motion. The SI unit of force is newtons, which is defined as the force in which acting on produces friction.
Rest will remain at rest unless acted on by a force. An object at rest will remain at rest unless acted on by a force.
The two types of force is contact force and field force. The contact force is forces the physical contact of two objects of a push or pull. For example, when a baseball is caught, it is stopped. A field force is a force that exists between two objects even in its absence of physical contact of two objects. When you use a compass, the needle will move due to the magnetic field that makes the needle point to the direction. When the objects are at rest or moving in a constant velocity, then all the forces acting upon it are balanced, called equilibrium.
Inertia is a tendency to do nothing or to remain unchanged. In this case, the ball had friction force acting upon it, but if there are no forces acting upon the object, then it would go the same speed and distance forever due to inertia. Newton's second law is the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and is inversely proportional to the mass of an object. The equation is F equals ma. The net force is an unbalanced force that causes the object to accelerate. For example, the object accelerates. We're going to hit both balls, one filled with water and one filled with air, with the same external net force. The air, the water. As you can see, the ball with less mass had a greater acceleration. This is because of Newton's second law. Net force and acceleration are inversely proportional to the mass. And net force causes the object to accelerate, and the greater the mass an object has, the less acceleration it has. The object with less mass will experience a greater acceleration, while an object with more mass will experience a smaller acceleration. Newton's third law is, for every action there is an equal and opposite reaction. This statement means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. Newton has recognized that a single isolated force cannot exist. Instead, forces always exist in pairs. When two objects interact with one another, the forces they exert on each other are called an action-reaction pair. By dropping the ball, it causes a force going down, which is the action, and the reaction is the force pushing on the ball, causing it to go in the opposite direction with the same force, which is an action-reaction pair.